Okay, we're live.
Hi, everybody, and welcome to the field trip. I am so glad that you guys could join us. I am Miss McGill from Palm Springs, and I am elated to bring you Benji and Ginger, who will take us through Jupiter Ridge Natural Area. Please feel free to use the chat to ask questions and engage with Benji and Ginger throughout the whole entire experience. Please make sure that you are appropriate in your chat. Please make sure that you do not spam by asking the same questions numerous times. I promise we will get to as many questions as possible. So please enjoy your time. Please engage. That way you guys may experience your own. And I will let Benji and Ginger take it away. Thank you.
Hi guys, how's it going?
Hey everybody. So my name is Benji and this is Ginger. All right, so like Miss McGill was saying, these field trips, if this is your first time, these are all about interaction. So I want to start off by saying thank you for dealing with the laggy video, but we are actually out here in the middle of a mangrove swamp in Jupiter Ridge Natural Area. And so excuse some of that lagginess, but we're here to answer your questions along the way. You guys are guiding this field trip. And what these field trips are all about is just exploring and learning along the way from what we find. So Ginger and I have been playing around in here. We've got some critters already
Cool
to show you guys.
We're always looking.
Yes. So we started out last month and we were in the swamp. We were in a freshwater swamp about 6 or 7 miles west of here. And now we're close to the mouth of the Loxahatchee River near the Jupiter Inlet here at Jupiter Ridge Natural Area. And what we're standing in is this historic swamp connection that used to connect Lake Worth Lagoon, which is south of us, to the Loxahatchee River. Lake Worth Lagoon was initially, until we dug the inlets, a freshwater lake. And when water level would rise in that lake, a little bit of it would trickle out and filter north into the Loxahatchee River. And we're sitting in that historic pathway that the water took. And we're sitting in a mangrove swamp. So what makes these trees special?
Oh, well, okay, there's a million things, but we can start with, how about carbon sink? Have you guys ever heard of climate change before? I'm sure you have. This tree is very important for that in particular. And I don't know if you guys can see on the ground here. I'm going to pull up a little of this. You'll see this is a bunch of leaves kind of decaying and becoming part of the detritus layer. There's a lot of mud, muck on them. And as they fall off of the trees, they create this nice thick organic layer on the ground. And that holds all this carbon inside. And it takes a long time for these to decay because this is a tidal system that we're in. So right now we're at low tide. And the other day we were out here, actually yesterday we were out here, and this was probably, I want to say up to our hip about. It was pretty deep. Maybe it was your knee if you're Benji and you're taller, but it was up pretty high. And so this is very important for carbon sequestration, if you guys have heard of that. And that's just one of the cool things about it. But tell us a little bit more about how that works.
Right. So carbon sequestration, right? Mangroves are trees that only grow in a tropical or subtropical environment like we live in here in South Florida. And that means that they're growing all the time. Okay, it's not like up north where they drop their leaves in the wintertime and go dormant. These trees are constantly growing, which means they're constantly taking in carbon dioxide, expelling oxygen, and they're using that along with photosynthesis to create energy and obviously to grow new leaves. So the reason why this carbon sink happens is these leaves grow, and when they get ready to die off, they fall to the ground. And because this gets wet so often, they don't decompose. And so that's the carbon sink. This carbon is now trapped in this organic material here on the floor. And this organic material that I'm holding in my hand, it looks like muck, mud, leaves. What this is it's the basis of this amazing food chain that happens in and around mangrove swamps. And we're going to show some of that to you today. One of the other things, Sam, I want to show is these root systems. Okay, so these are red mangroves. These are red mangrove trees. This is the species of mangrove that grows in the deepest water. There are 3 species of mangroves. This one grows in the deepest water, and it has what we call prop roots. So these prop roots extend up the trunk, and what these allow the tree to do is to feed oxygen to the roots, even when part of the roots are submerged. So that's really, really important. The other thing that these mangroves and these prop roots provide is this kind of woven web of protected habitat. And so this web of habitat serves as a nursery ground for just this incredible amount of fish species, of crustaceans, crabs, and things like that. Sharks, even baby lemon sharks and blacktip sharks, will cruise in and through the edges of the mangroves, looking for food and staying hidden from larger predators. So you can see how tangled this web of roots is. And every time the tide comes up, all those little fish rush in here to grab that protection that all this structure provides. So we are sitting in the nursery for a lot of fish that are really important that we eat, things like snapper and grouper that we catch out on the reef 5 miles offshore, but they start their life right here. I'm going to take the camera. Sam is tangled in the mangrove roots right now.
You can see how it
Benji,
works.
we have a question. We have a
Sure.
student who would like to know how come there are so many decaying leaves on the ground.
Right. So we talked about the reason that there are so many decaying leaves is because they don't decay very fast. Okay. So say in like a forest that's above water, when the leaves drop to the ground, for decomposition to happen, you need oxygen. Okay. And because this system here, right over here, there's still water even at low tide. Because this system stays so wet, when there's water at the base of these trees, it creates what we call an anoxic condition, a condition without oxygen. And because of that, the decay happens much, much more slowly than it would on land. So not only do you have trees that are growing all the time and dropping leaves all the time, but the decomposition that turns leaves into mud and sediment doesn't happen very fast. And so that's why it creates a lot of these leaves on the ground, and that's what really helps out with climate change. So, Ginger, another thing that makes mangroves really important for climate change, while we're talking about that, because when we're on this trip, we want to kind of focus on anthropogenic impacts, so impacts of humans on the system.
Yeah.
And climate change is a huge one of those. Another thing that happens with climate change is increased and higher intensity storms.
Yes.
Right?
Mm-hmm.
And so mangroves and mangrove forests actually help protect us, right?
Yeah, absolutely.
So yeah, let's get Sam out of this tangle. And Ginger, I want to just talk a
Benji,
little bit about...
there was a question of how is that estuary area actually created? So we know that all those mangroves work together to act as a nursery and a protection for small juvenile fish, but how is that area actually created on the shoreline and it's not someplace else?
So it's a great question. So an estuary at its basis is the confluence where freshwater and saltwater meet. Okay? And so what you have is this condition where the water is not as salty as the ocean, and it's not as fresh as the river. And so what we have is water comes from rain, it falls on the land, and it flows through swamps and wetlands and eventually tributaries into the Loxahatchee River, and then into this system that we're at the edge of. We're going to go explore the water here in a second. But what the mangroves do is they find that edge where kind of the area between high tide and low tide. Yeah. And that's where they have evolved to take advantage, and they've outcompeted all these other trees that can't deal with salt water.
Yeah.
So Ginger, I want to continue with that before we get to why these are important in protecting us from storms.
Yeah. Do we want to talk?
But what makes mangroves able to survive in salt water?
Yeah, well, there is a million different, well, not a million, there are a few different adaptations here for red mangroves in order that they can live in this brackish water system that we're talking about. So there is salt in this water. And if you were to go and plant a normal tree, it wouldn't live in this water. This is specifically adapted for this. And so it goes about that in two different ways. And the first is that it excludes salt from the roots to begin with. So this area here, it keeps salt out as much as it can. But salt that gets in, I'd like to show you.
That's a coin vine.
Is put, oh, where is one of these? Here we go. Sacrificial leaves. If you can find one. There's one. You got a good one?
Sorry
perfect.
about that.
Okay, so this is a yellow leaf that just came right off of this mangrove here. And if we look around, we'll see some more. Here's one actually right above Benji's head. These are called sacrificial leaves. And so the salt that is not excluded from the base and the roots that goes up into these sacrificial leaves. And so these are the most salt concentration there in the plant. And they'll drop off first. And so that allows the rest of the plant to do its respiration and its activities with major adaptations in order to live here in this brackish water system. So they're really, really neat trees. And there's another mangrove that we'll get to in a few minutes that has a totally different way that it excludes salt from its system. And so we'll show you.
We're going to change is this increased intensity and frequency of storm events.
Yes.
So why are mangroves so important to protecting us when we're having more and more intense storms?
Okay, well, that has to do with erosion. And so this system, as you can see, these roots again are really good at breaking up wave energy. And we haven't gotten to the shoreline yet, but you'll see when we get to the shoreline, there's waves from all different sorts of things. And they increased by and things like that. And these mangroves, tangle of these roots are really great at dispersing that energy and making it less. So you have a big wave and it hits these mangroves and it disperses the energy. And that way it's not eroding the shoreline. And so you'll definitely see some of that as we get a little closer to the shoreline. But just imagine that, a wave hitting all of these tangles of roots and how that would react.
So if you have a mangrove forest in front of... Yeah.
The students want to know how many different types of mangroves there are and if they have different functions on that shoreline.
Right. So there are 3 kinds of mangroves, and then there's actually another one that's a very close relative. We'll see it later, called the buttonwood. But there are red mangroves, which this is the swamp we're in right now is dominated by red mangroves. They're the ones with these prop roots that come off. The second species, and what I'm going to do is, Sam, if you can pan over here, and if you imagine the shoreline like this, and up here you have your upland with your house, and down here is your water. Red mangroves live in the deepest part of this kind of shelf system where the tide goes up and down. Next is the black mangrove. So we're going to find them. Instead of prop roots that come off of the trunk of the tree, black mangroves have what we call pneumatophores, and they're these little roots that look like fingers that come up out of the ground. So they're higher up on that shoreline. They're not in as deep of water, so they don't need these really robust prop roots to get oxygen to their roots because they're not in quite as deep of water. And then finally, almost up at the very top of that tidal range is the white mangrove. And so you have 3 species, and they're really oriented based on water depth. So I hope I answered that. The other thing I wanted to point out, Ginger, is when we walk over to the shoreline, you're going to see that this muck and all of this detritus and leaf material, it's going to disappear. We're going to see sand. So the other thing that the mangroves, especially the red mangroves, do is not only do they break up wave energy, but they also help to stabilize the soil with these roots. The other thing that these mangrove forests are great at doing is showing us really right in our face some of the impacts that we have on the land here. and they are great at trapping trash. So a whole lot of the trash that ends up in the water, and you think, oh, well, this is probably from boats, right? Well, it might be. But the other thing that happens is water flows off the land. And so when we throw our trash on the street, it ends up in the sewer, it ends up in the drainage system, and finally it ends up in the estuary. And ultimately, if it doesn't end up in the mangroves, it ends up in the ocean. So that's another thing that the mangroves are really good at doing, is telling us the impacts we have on the land. Yeah, Heather.
Benji, they're noticing that the leaves of the mangroves kind of canopy out and kind of envelop that whole area. They want to know, how would other plants grow there if there's barely any sunlight or space for them to be able to get the sunlight for photosynthesis?
Right. So mangroves really do create this monoculture, meaning when you get into this deep red mangrove swamp, that's the only plant that lives here, and that's because it's the only plant that can survive in these conditions of brackish water and water depth. There, if we look down here, Sam, you can see this is kind of a new mangrove that's growing here. It's short, it's little, and we'll show you some of the seeds later. But these guys will start out and they'll kind of wait. And just like in the rainforest, if a storm comes and one of these mangroves dies off for some reason and it falls over, and that allows light to come down into the mangrove forest, then these small mangroves that have already started are going to take off and they're going to shoot up and catch that sunlight. So it's very similar to the rainforest in that aspect. You do have like a total canopy here. But when space does open up and sunlight hits the floor, that's when all these new little mangroves take off and fill that space. Okay, so
Benji, they want to know if the mangroves do any other protection besides the animals that are in the water. Do they protect anything that's outside the water, such as the birds?
Oh, they do, and we're going to talk about that. So I'm so glad you guys asked that, because even though this looks like you're not seeing any big animals move around behind us, this forest is so full of life.
Full of
life, right? We were shaking a tree earlier. We had a mangrove crab fall on me. Ginger just picked up a little piece there.
Right now, if you guys want to take a peek at him, this is a root mangrove crab. A tree mangrove crab. And it is the day of the crabs today. You guys are going to get to see a ton of different crabs that we've seen. And remember, we're going to keep our eyes peeled and look for as many animals as we can find in here. But this is a really, really rich system with an amazing food pyramid in here, food chain. And so this system is filled to the brim with life.
So I'm going to put this guy right here, and actually down in this stump, I can see two other mangrove crabs. There's some snails on the outside. This is a periwinkle, right?
Periwinkle, yep.
Yep. So there's a periwinkle right there. There's just so much life, and look at this crab, just does not want to get off of me. He's just hitching a ride.
They like the crab, Benji. Yeah. He's the hit of the show right now.
Did he go up your shirt?
He might have.
Yes, got it.
We've got a crab in the shirt.
Yeah, today's the day of the crab. We've been catching a lot today, and so
no,
you never know what we'll find in here. I think he jumped out.
If the crab didn't jump off, then I'm going to feel him later. Oh yeah, he's on the ground.
Oh, there he is. Okay.
All right.
He blends in pretty well.
Ginger, can you show us a propagule by any chance? They're asking about what the mangroves are produced by.
Yeah, they're all over the place. So here we go. Yep, I got a great one right here. Actually, he's a little broken up here, but we have a propagule right here. And this is essentially what you would think of as the seed. Okay, so these are floating. This is coin vine again. Keeps fooling me. They're floating in these areas here on the leaves. And there's a little cap to it. If we can find one of those, you'll see, but it's attached to this sort of base of the leaf. And it drops off of the tree and it floats around until it can anchor itself in the sand. And you'll see all these different stages right here. So this is actually perfect, because here's our initial propagule. This one's a little beat up, like I said. And you guys might have heard of them as sea pens. I used to call those sea pens when I was a kid, but now I know them as propagule. And you'll see all these roots here. And here it's got a few little leaves. So this guy is pretty healthy. So I'm going to go ahead and put him back. And we'll put him right back next to one of these, which is at a different stage of life. And so you can see.
Protected? Ginger, are they protected in Florida?
So they are absolutely protected. And the protections are important for you are not able to cut them or disturb them, anything like that.
Right.
So be careful if you're climbing around them. We're not trying to break them or anything. And so they're highly protected here in Florida because, as we've spoken, there's a million different reasons why these trees are so important to your health and the health of the ecosystem.
But if you guys are climbers out there, I highly recommend climbing around a mangrove swamp.
It is fun.
It is so fun. All right. So
they want to know if any animals eat the propagules.
Yes, and we're going to see one a little later.
I'm going to bring this bag with me.
Hold that question because we're going to see one a little later. So we're going to kind of take the trash out here. I'm going to grab this camera from Sam. You guys are going to come out with me.
Oh, they want to know, how are the red mangroves regulated?
Okay, so there you go, Sam. All right, so the red mangroves are regulated by state statute, and we're going to come around here, Sam.
Yeah.
So that we're not pointing into the sun.
Yep.
So they're protected by state statute. There's actually a state law that protects the mangroves. So mangroves are always part of a wetland system, and there are regulations that restrict what you can do in wetlands. But mangroves are so special and so important that they kind of deserve their own rule, their own statute. And so that is how they're protected, is by state law. If you even want to trim a branch of a mangrove, the only way you can do that is by hiring a certified professional mangrove trimmer, a PMT. And these are folks that have been through training. So you can't hire any tree service to come. These are folks who've been through training, and they know specifically for mangroves how much they can trim, where they can trim, and how they can do that to make sure that they don't impact that tree.
Absolutely.
Yeah, so really a tree that deserves the protection that it has, really, because it's such an important part of the base of life in the estuary.
Yeah, and we've talked about a few of those reasons so far. And you'll get to see them with your eyes as we get closer to the shoreline.
So, Sam, what I'm going to do, okay, Anne's giving me a time check. What I'm going to do, Sam, is I'm going to hop down here, and then I'll grab the camera from you so you can get out.
Thank you.
All right.
I can go crawl this way.
You guys can see Benji.
Ginger, I don't know if you can hear me. They want to know, how many years of training would a PMT need?
I believe it's just a few classes, but I'm not sure. That'd be a great thing to look into for you guys. So what I want to turn around and show you here is, so we've got Anne, who's behind the scenes. She is taking all the cool photos that you guys see. I want to give her a little credit. She doesn't like to be in front of the camera. This here is Carrie, and Carrie's our site manager. And wow, does this shoreline look different than what we just saw, right? So now what you see is this
beach.
Yeah.
Right, exactly. So you've got this beach sand. Thank you, Sam.
We went from that muck to this beautiful beach sand here.
Right, and the source of that sand, if we can come right over here, is erosion from uplands. So this is this beautiful sugar sand, this really white crystals. And where this come from, Alicia is another one of our teammates, and she's out fishing right now trying to catch some stuff for us to look at. But she's a geologist, so she studies rocks and minerals. And she reminded me where this stuff comes from. And this actually, does anybody know what the Appalachian Mountains are? The Appalachian Mountain chain. And if you guys do, it runs from the Northeast up in New England all the way down through the Virginias and North Carolina and into Georgia. And it's this ancient mountain system. And it is mostly made up of quartz, which is a type of rock, a type of mineral. And over millions and millions of years, those mountains have eroded and the sediment has come down the Florida peninsula. And that's what makes our ridges and our dunes that we have down here in Florida. And this is the sediment that is the base of this really amazing habitat, and it's called Florida scrub. And so what we have right here is the meeting of the estuary and Florida scrub. So if you can see this really sharp embankment, there's about 3 feet here between my foot down at the base of the sand and the ground level. And if you look right here, Sam, there's even a cactus. There's a prickly pear cactus right over here. So Sam, right over here. Right. So it kind of tells you how dry this system is right here at the edge of the estuary. And what the Florida scrub is made of is this white sugar sand. You can see it next to the cactus over here. So,
Benji, they want to know what's so different about that sugar sand compared to other sand.
Right. So, a lot of other places here in Florida, out west in the swamps, we still have that sand, but there's a lot more of an organic component to that sand because the water table is so much higher. Meaning there are a lot of swamps and wetlands. They may dry out in the dry season, but in the wet season they get underwater. And again, that produces that anoxic condition where things can't decompose. And so these organics, this muck builds up in the soil. And so that's kind of, you get soil and sand with a lot of organics out west. And as you get closer to the coast and you start to see some of this elevation, the dunes, these natural dunes that we get near the coast, that's where it's just sugar sand. Because you get this elevation, rain falls, but it goes almost immediately through that sand because the water table is way, way underground in the scrub habitat. So
Benji, they'd like to know if it's common for the cactus to grow in that area, for it to be that close. Is that common for it to be right there by the water line?
The next thing we were going to talk about,
well,
actually.
Right.
That's
so,
the perfect transition
yeah,
for that,
perfect
absolutely.
segue, yeah.
So, okay, so what that has to do with, you saw that embankment that Benji pointed out to you, where it was from his knee down to his ankle there. And that's caused from erosion. And we have a really amazing example of erosion right over here if you guys want to follow me. Can you guys see what this looks like? What does this look like to you? So we have sort of root systems. And then if you go up, it doesn't look like a red mangrove. So it looks kind of almost like those prop roots, but it's not. What this is an old pine, a sand pine.
It's probably a slash, yeah.
Okay, this is probably an old slash pine, and it is dead, as you can see at this point. But all of this would be where the original land was. This is the top. This is where the soil would be. And so all of this has been exposed due to erosion. And that's a huge amount right there, because it's coming from my hip all the way down to the floor there. And so again, that's why that cactus is so close to exactly what's happening right here with the water. It's that erosion. And so one thing that we've done here at Jupiter Ridge to help combat that erosion and help out our mangrove friends who are doing such a great job at holding onto that soil, we gave them a little help here. And I don't know if you guys can see these rocks here, these big piles of rocks here, but those are breakwaters that we have installed in place there. How many years ago was that now?
This was about 7 years ago.
So,
and I want to get out of the way so you guys aren't staring in the sun.
Yeah, that's probably a good idea. We'll turn.
So the reason why we put these breakwater systems in to protect our shoreline is because by the time that we installed these as restoration, we were literally losing an average of 3 feet of land a year. think about that. 3 feet of uplands every year was getting eroded into the estuary. So what do you guys think could have caused that? Like, why are we getting this crazy erosion right here along the shoreline when we're inshore, right? There's not enough what we call fetch or distance to produce big waves like you see in the ocean. So what would be eroding the shoreline and constantly producing waves?
Who has some guesses out there? What do you think is causing all this erosion out there? Put some guesses in the chat for us.
All right, and so we'll wait for those guesses.
Okay, perfect.
But Sam, if you can come right over here, I want to show you guys what these breakwaters are doing.
Oh, here we go. This is perfect.
You have some guesses coming in. You have guesses of tide change. You have guesses of boats, guesses of water and wind. You have guesses of storm and humans.
That's right. So you guys, there were some right guesses there, and it's us. That's the reason for the erosion. It is nothing else but us. So it is us recreating out here on our boats. This is a high speed zone, as you just saw that boat whiz by. We get a lot of larger boats in this area.
Absolutely.
And so they will be throwing wakes. And
You'll see this
Sam,
right here.
if we can point away from the sun right down here. And you can see this is a pretty mellow, small wake. You know, that wasn't a very big boat. It looked like a big boat to me. But there are 50, 60, 70 foot long boats that come through here, and they will throw boat wakes that will be, 2.5 feet, even 3 feet tall. I've been flipped over in my kayak because of these massive boat wakes. And so those boat wakes will crash into the shore, and they eat up that sugar sand and erode it. Now, Sam, if we can come back over here, I want to show you guys what has happened since we have installed these breakwaters. Maybe you can introduce us to this other mangrove species?
Sure, absolutely.
So Sam, if you guys can still hear me, and we look right down this edge, we can see this spit of sand that has come out here. This is actually the land. You can see it. It is healing itself. So we installed this breakwater here. And now what's happening is these boat wakes come through the little breaks in the breakwater, and they actually move sand in and sediment that's in the water, and it accretes or it builds up behind these breakwaters. So in areas where we put these breakwaters in, we're actually gaining land back. It's coming back. And just what we saw in the mangrove swamp, we've got naturally recruiting mangroves right here on the shoreline. So this sand is building back out, and now we have new mangroves that are starting life. Look at this tiny little mangrove. It's already got a little periwinkle snail on it. And so it's starting the process of restoring this mangrove edge, this mangrove swamp to the system, because we put these breakwaters in to help it. Now, I want to go back to
Benji, really quick before you go too far away, they want to know a little bit about, is there a wake zone in that area or no wake?
Right, so there's not. In this area where we're in, this is a high speed zone. So boats can go, it's during manatee season, I think year round in this spot, it's limited to 25 miles an hour, but a 60 or 70 foot boat going 25 miles an hour is throwing a huge boat wake.
Benji, they also want to know, you were standing in that water right there, you and Ginger bravely, and I see Ann standing in it as well. Are there any kind of animals that are in that water?
Oh,
That's what we are working on right now. There is a plethora of animals in there, and we will have to catch up with Alicia in a little bit and see what else we caught.
yeah. So I think we've got some stuff in a tank we're going to go check out.
We're still catching.
But I think I know what you guys are asking about.
Okay.
I think I know what you guys are asking about. So, where we are, this is in the Loxahatchee River and Lake Worth Creek Aquatic Preserve. Okay, so this is a really special natural water body. It's designated as an aquatic preserve, which means, again, more special protections from the state. Um, one of the reasons why this area is so special is because it is a nursery for bull sharks. All right, so bull sharks are these amazing sharks that can actually withstand fresh water. They've been found 1,000 miles up the Mississippi River. It's crazy. And they come into the Loxahatchee River estuary to have their young. So different shark species reproduce in different ways. Some leave an egg sac and the young are kind of on their own. Bull sharks give birth to live young. So they give birth to live sharks. And they have these really important estuaries all around the world where these bull sharks give birth to their babies. And the reason that they pick these estuaries is because of the abundance of food for these little sharks. And so the fact that we have this bull shark nursery where they're giving birth to live young here is a sign of how important and how productive this ecosystem is. So sharks, there's spotted eagle rays, there's manatees, there's sea turtles. They're all in this estuary right here.
So, Benji, normally we think of a shark as a predator. Because they're pup sharks, they're baby sharks in that area, are they prey to anybody in that area?
Oh, absolutely. Absolutely. So, and remember when we were in the mangrove forest, I said you have baby lemon sharks and black tips and nurse sharks and baby bull sharks. They will use the mangrove edge to hunt, but they will also use it as cover. So, in the fish world, it's if there's a bigger fish, you better watch out. Okay. So there's big fish in here. There's big fish like big snook. There's grouper. There are these fish species that get really big, and they will easily eat a baby shark if they can find it. So yeah, they absolutely. So
Is there a certain season that the pup sharks are normally in that area, or is it year round?
You know what? I'm not sure. That sounds like a good research question for afterwards. Is when is pupping season for bull sharks? So it's getting breezy out here. So we're gonna kind of try to duck back in behind the pine. We'll check out some of the animals. But on the way, I want Ginger to show you guys. Yeah.
So back to mangroves again and how amazing they are at excluding or excreting salt. So excluding, and you saw that the red mangrove did both. It excluded from the prop roots, right? But it also excreted into those sacrificial leaves. And this one up here has an altogether different strategy. So this right here, I don't know if you guys can see this. This is a black mangrove, and you'll see on the top it looks pretty green, but on the bottom of the leaves here, it's got a very silvery kind of crystal looking kind of substance on the back. And what that is actually is the salt being excreted on the outside of that leaf on the back. And you can even taste it. It's pretty salty. And so that's the way that they are excretors, salt excretors. And that's the way that they survive this saline system. Another way that we were talking about was their root system. And if you remember, the prop roots on the red mangroves kind of look like rainbows. This guy here has these finger-like structures that we were talking about before. And these are called pneumatophores. And to me, they almost remind me of like a snorkel, right? So it needs air exchange, oxygen exchange in order to grow. And so these stick up above the tops of the anoxic soil, right? There's no oxygen inside here because it's completely covered in water. And remember, the water will come up above these as well too, but it's sticking out and allowing for that air exchange. And so that's a very important function of this black mangrove. And the third type that we have here is a white mangrove. And I don't see any good examples of him right now because if you remember, the white mangrove, it goes red, you're going low, red, black, and then white. And so they're a little further up in the system.
There's something else really important at the base of that mangrove that is so
oysters.
important in the estuary. I wanted to show on the breakwater, but it gets a little deep out there.
Yeah. So, okay, this is, Benji just pointed these out to me. And yeah, these are incredibly important. These guys are oysters. And so what they do is they are filter feeders. And you can see just how many of these there are on the base of this black mangrove. And they are incredibly good at filtering the water and using that to grow and for food. And so each one of these, they say, at its height, can filter up to 50 gallons of water a day. And so if you imagine a big giant bathtub and all of that is completely filled with water, each one of these little guys can filter 50 gallons a day of that. And they're an important part of the food chain as well. And different parts of our estuary system along here, birds will eat them. They're great for hiding little tiny crabs in. And they also make a thing that is almost microscopic. You can't really see it, but it's called spat. S-P-A-T. And so spat is the larval form of this oyster. And so it will float around in the water, and that's a really great part of the food system. And when the spat attaches to a substrate, so a substrate could be a rock, like the breakwaters that we built, or a root, like this black mangrove here. When it attaches, it can grow from there.
All right. So I think, Heather, really quick, what kind of time are we at?
You have 19 minutes. You're good, Benji.
Okay, cool. All right, so I want to bring you guys over and show you some of the animals that we found.
The day of the crab.
Yes, this is kind of the day of the crab here at Jupiter Ridge. So we've got a bunch of different crab species. We also have some fish species here. And so what our other team is doing right now is they're pulling a seine net. And so it's a net with poles on either end, and they're pulling it through the water to try to catch some of these fish. And I think they must have our little nets, mustn't they? Because I don't see our nets here. So let's check out some of these fish here. So right here, this is a tiny little bait fish. And I want to see if I can open his mouth. So this guy, let's see how big his mouth is. Oh, this is. Okay. So does anybody have a parent that likes anchovies on their pizza? So this is an anchovy. And the reason that I know that is, all right, so look at that mouth. Look how huge that mouth is compared to how tiny this fish is. It's
how
massive.
cool.
Can you see that?
Yes, we can see that, Benji.
All right,
Very clear.
So the anchovies, what they'll do, I'm going to let this guy go there. And what they will do is they'll swim through the water in these schools of just millions and millions of fish. And they all have their mouths open like that. And that's because they're filter feeders. Okay? So they'll just, like oysters, filter the water as they swim through. Now let's see if I can find another one of our bait fish here. All right. So this guy, you can see a little bit of green on the back there. And this is a herring species that's pretty common around here. Our locals, they call them greenies. And you can see just that brilliant silver side there. And so these guys eventually will get about this big. I'm going to let him go. But again, another just super, super important part of the food chain. They're really, really common in the estuary here. And then there's a bigger fish here. And I don't know that I can get him because he's a little speedy. But if you can see him there, Sam, that is called a mohara. So again, another one of our smaller fish, another one of our bait fish here in the estuary. Oh, got him.
Wait.
Oh man, you guys check this out.
Big wave right at you.
This is what we're talking about.
There we go.
Look at this wave action. Watch our other crabs there. I mean, this is why. Oh, I lost my mohara. Sorry, guys.
We almost lost our bucket here.
Well, I'm glad that happened, guys, because that's what we were trying to show you. That's one of those anthropogenic impacts. Now, we're going to go through a series of crabs here. And we've got, let's see, one, two.
Betsy, as you're talking, there was a question about what's the difference between a filter feeder and a bottom feeder?
Okay, so a filter feeder is going to literally filter the water. So oysters, they're just taking in water and they're expelling the water, but filtering out any particulates that are in that water. Kind of a bottom feeder, what we would call a bottom feeder, are these animals that literally go and eat the detritus, right? And one of those is the mangrove crab. Now, the mangrove crab will also eat leaves, also eat mangrove leaves, but these guys are omnivores, okay? They're omnivores, which means they're going to eat plants, they're going to eat animals. They will, these mangrove crabs, mangrove tree crabs, have fish scales in them. Yeah, Ginger's got some mangrove leaves with scrapes here and little bite marks. So you can kind of see this is what these mangrove crabs eat. And these crabs themselves can be responsible for over 90% of what we call herbivory in the mangrove forest. So they're kind of trimming the mangroves and keeping them healthy. But they are also, what you would call kind of bottom feeders, because at low tide, they'll go down into that leafy, mucky layer, and they're going to pick up literally any piece of organic material that they can find, fish scales, little nematodes, tiny little organisms, but also leaf material. And so that's kind of the difference between a filter feeder is literally filtering the water. A bottom feeder is kind of picking up little bits and pieces that have settled out to the bottom. So this is a mangrove tree crab, like I said. There's actually two of them here. There's another one right over here. So you can see this one is a female. She's got these small claws. And the female mangrove tree crabs let the males kind of do all the pushing around. And so this male right here, you can see he's got some bigger claws. There, show us the claws. Hey, there we go. So you can see that beautiful red on those claws. So this is, again, the male mangrove tree crab. All right, now we're going to go to a different mangrove crab. And this is the mangrove root crab. This crab looks a little different. Let's see if I can get him out here. Man, he doesn't want to come out. All
There
right.
he is.
Relax, buddy. We're going to play it nice. All right, check this guy out. So, this is the mangrove root crab. You can see this beautiful white on the side. He's got this hair on his legs. And this is obviously a much bigger crab. And so these guys are more feeding on the detritus that's at the bottom. They're actually feeding, like their name implies, on mangrove roots and propagules. And they're omnivores as well. And if they can catch them, they will actually feed on the mangrove tree crabs, those smaller ones we just looked at. So again, remember I said, if you're a small fish, you better watch out. If you're a small crab, you better watch out too. Now, I feel bad about this, but I wanted to show you this. This is a defense mechanism. You'll notice this guy doesn't have claws. Well, that's because he shed his claw when I dove through the mangroves to catch him. So this claw was attached right here. And you can see that claw is this beautiful white color. These are strong claws. So he gave me a pinch and made me bleed a little bit, which I probably deserve. I definitely deserve. But the defense mechanism of this crab is very similar to that of a lizard. Have you guys ever tried to catch a lizard and you grab it by the tail and all of a sudden the tail just falls off and it's wiggling around? So that's a defense mechanism. So what this crab did is first he pinched me, which I deserved. And then he figured out that wasn't going to work. And so these crabs actually just shed their claws. Their claws just expel them right off. Now, you can see that this crab is not bleeding. So there's no harm there. And this claw will regrow within a couple of months. This isn't going to affect this crab's ability to feed on the mangrove propagules or the detritus or anything. So he'll be all good. We're going to put him right back in the swamp. But really, really just a cool example of the food chain right here. We've got the mangrove tree crab and the mangrove root crab, and one of those defense mechanisms, which is just shedding that shell.
And Carrie just brought over to me the tiniest little mangrove crab ever. And you can see
teeny tiny.
the little varying sizes here of these guys. And another defense mechanism that I was reading about just today, and again, that's what I love about environmental science, is that you are always learning. There's always something to learn. Another one of their defense mechanisms is actually to climb the trees and to get away from predators that way. So they're down there, feeding on the detritus. But one of their defense mechanisms is they're great little climbers, as we saw earlier. And you saw them all over those roots and up that tree. And this guy gave us a little bit of a fight, but we got him.
So there you go. I mean, those names, though, right? The mangrove tree crab, and that's because they are generally going to be higher in the tree and trying to probably get away from those mangrove root crabs. So we've got another crab species.
Benji, are any of the crabs that we saw today endangered at all?
No, these are all very common crab species. The diversity of crabs in Florida is really incredible. And so all the crabs we're showing you today are super, super common. But the one I'm going to pull out here, I'm going to try to get him without him pinching me. Let's see. So this guy is more of a crab of the shoreline. Whew. All right. And do you see his enormous pincher there? So this is a male fiddler crab. And these are the ones that are going to be all along these sandy shorelines. And they have these little holes that they'll go into when the tide comes up. And this we can tell very easily by that huge claw. This is a male. And if you guys end up down at the edge of the estuary at low tide, you will see just a sea of these, thousands of them moving around all over the shore. And every now and then, there's a pretty cool time lapse on our YouTube channel. We can maybe send that to you, Heather.
Okay.
These male fiddler crabs will actually dance together in unison, and they'll move this big claw of theirs up and down and up and down. And it's kind of this territorial display. So again, another one of these crab species that lives in the estuary. And one of the reasons I think this is so cool today, what we found, we didn't find any huge animals, but the diversity of these crabs that live along the shoreline and in the mangrove swamp just shows you that all these guys are eating even smaller animals, detritus. And so these guys are like one step up on the food chain. We've even seen, crabs that eat other crabs. And all of these provide really valuable food sources for fish, for birds, and all of the bigger predators that are in the system. So I'm going to let this guy go, and we'll check out another one of our crabs. He doesn't want to leave. Come on, buddy. Go on. All right, he's going to hang out with us.
Benji, they kind of have a question about how many crab species are out there since we've seen so many so far. Estimated.
Oh my goodness. That's another good research topic. I don't know if saying over 100 would be out of the question, but you have these terrestrial crabs, right? Like these fiddler crabs that'll live in this intertidal zone. The mangrove crabs, there's one in the water right now, and he's kind of half submerged, half not. They'll spend most of their time out of the water. But in Florida, we have these things called the blue land crabs. So he's right there. So we have these giant blue land crabs in Florida. And then if you guys can see in here, we have hermit crabs as well. And all of these crabs are not even the swimming crabs that we have in the water. Let's check this out, Sam. Can you guys see that?
Yes, we can see them.
Yeah, so there's a big hermit crab there. We've got 4 of them here in the tank. They keep kind of going between, fighting over which space is whose. And I'm guessing that there's multiple species of hermit crabs that are native here. And then you have all the swimming crabs like blue crabs. So that's a great question. And I honestly wouldn't know if the answer is over 100, just under, but there are certainly dozens of native crab species here.
Benji, just so you have a time check, you have 5 minutes.
All right. So, I think 5 minutes left. What we really wanted to cover today was the mangrove swamp. We wanted to cover erosion, anthropogenic impacts, and we wanted to show you what we have caught so far. So I think we've pretty well gone through everything in the tank. What kind of questions do you guys have? And I also, while you guys are thinking of questions, I want to scan over here. So we've got Sally over here and Alicia, and they've been rock stars pulling this seine net and trying to get us animals. To show you guys, again, Carrie, the site manager, is here. So she actually manages the land here. She makes the decisions of, what areas are we going to prep for prescribed fire. She does the monitoring to make sure that, our listed plant species, our rare and endangered plant species, are doing well. So there's a whole lot of experience around a whole lot of different, aspects of science. And I think that's one of the really cool things about science is I did environmental science in college. And in a million years, I never would have thought I would be doing what I'm doing now, which is try to inspire you guys to get into science yourself. So Alicia is a geologist by training. She spent time as a teacher as well. And now she's doing outreach. And before that, she even worked in climate change. So the sciences...
Fishing!
She's fishing. So the sciences are so cool because there's so many different avenues of what you can do and what you can get into. Sorry, Sam. So anybody have any questions about the estuary, about, Ginger and myself, our careers?
There was a question. There was a question that came in that they want to know, is there a time of day where the animals are a little bit typically more active than other times of the day?
Right. So that answer totally depends on what kind of animal you're talking about. So there is there's kind of an old saying, with fishermen, it's the golden hour. You want to go out in the morning or in the evening. Fish also depend on tide changes and tidal flow. Mammals will also kind of follow a similar kind of pattern where, deer and bobcats and coyotes, they'll be active at the edges of the day, morning or evening time, and even at night. They're really active, especially in Florida because it's so hot during the day. So you'll get deer that will be bedded down all day and they'll be out feeding at night. But then if you move to something like reptiles, right? Reptiles are going to spend the morning kind of warming up, like things like snakes and gopher tortoises. So when we got here, on our way over from the parking lot to where we are at the shoreline, it's about a half a mile drive.
About that, yeah.
Between the parking lot and here, we saw what, 3?
3, I think,
So
and then there was
3.
one over here. So
4. So 4
4
black
total.
racers this afternoon, and there's and gopher tortoises as well. They'll spend the morning kind of warming up, right? And then in the midday and the late afternoon, those reptiles are going to be super active. So yeah, the answer
Benji,
really
quickly, they have a couple of job questions really quickly. If you could answer those before we jump off.
Yeah.
They want to know a couple things. What do you guys do for your everyday day job? What's your favorite part of your job? And what degree do you guys have to do what you're doing right now?
All right, so I'll start first.
Sure.
My day job, a lot of it deals with planning to do things like this. So we don't just jump out here and come out and hang out with you guys. There's a lot of planning that goes into these things. We do different things like plan festivals and different adventures. We have an adventure series called Adventure Awaits. We're going to get ready to start back up. So there's a lot of planning that happens. My favorite part of the job, this is it right here. It's leading these trips because I feel like a kid. There's no shot that I should be getting paid for diving through the mangroves and catching crabs and hanging out with you guys.
Yeah.
So that's definitely my favorite. I have a Bachelor of Science in Environmental Science from the University of Florida. And I started my career as a wetland regulator. So I regulated development and protected wetlands. And then I spent 9 years doing wetland restoration design. And then, through photography and my interest in that, I kind of jumped into outreach. And I definitely say that outreach is
this is pretty
definitely
fun.
the best job.
This is pretty fun. Yeah. So piggyback on that. I would have to agree with Benji. This is probably my favorite part of the job. I love going out and talking to people and just getting them excited about what I'm excited about. I mean, it's beautiful. I love being outdoors and I love answering questions and inspiring you guys. And I would love to see your faces one of these days out here in one of these natural areas and we get a chance to do that. And so you should really check out that Adventure Awaits series, which we're going to be doing here in a little bit. We've got kayaking events, hiking events, and they will be in little smaller groups at the moment just because we have that pandemic going on. But so my everyday job is actually a little different. I do a lot of mapping. And so that involves a program called GIS. And so that stands for Geographic Information Systems. And so we map everything from birds' nest sites to exotic vegetation to very rare species of plants and animals. And so that helps us to visualize the natural world around us and help us protect it and make decisions about it in the future. And then for me, and able to get that, there's many different avenues that you can do, but I got my Bachelor's of Science in Environmental Science and Policy, and then I went on to get my Master's in Soil and Water Science. And I started at ERM as an intern, actually, doing mapping. And so I have been with them for over 10 years now. And so there's a lot of different avenues to get there.
What do you do the other half of the year? Come on.
The other half of the year, I live in Montana. It's pretty far away, near the Canadian border. It's really cold. And I do a lot of mountain hiking. And I monitor species like mountain goats, pikas, which are in the rabbit family. They're so cute. Look them up. Or we'll send you a picture. And loons. And so I just love my job and being outdoors.
Yeah. All right. Heather, we got anything
guys.
else?
Nope, I think that's it for right now. They are so thankful for this experience. You got lots of thank yous. And we appreciate your willingness to do this every single month with us and take us out in the great outdoors into our backyard, and we can't wait for next month. So thank you guys very much.
Absolutely. Come back next month.
Yes.
I promise you we will be back in some kind of muddy water, swampy estuary situation.
Yep.
And hopefully we'll have some animals to show you as well. So
Animals.
thank you guys so much.
Thanks for having us.
Yeah.
It was fun.
Thank you.
Had a great time.
See you guys.
next
Thank you.
Cheers. Get outdoors.
Awesome.
Please make sure you guys fill out that survey if you have not already, the one that's in the chat. And thank you guys so much for joining us. And we hope to see you guys next time. Thanks so much.